Alright, Algebra 2 students, welcome to our video on counting, permutations, and combinations. Alright, so I'm in my classroom, so the heat's going to come on soon, and I apologize for that terrible noise, but this is the time I got. And in the background, I'm going to go ahead and play Apple Radio, the Beatles station. Okay, so counting, permutations, combinations, and I promise you'll understand the meme before the end of the video. Okay, definitions. Counting is finding the possible number of outcomes for an event. So counting is kind of the precursor to probability. You need to know the number of outcomes before you can express a probability. And I know we talked a little bit about probability in class the other day. If event M can occur in M ways and is followed by event N that can occur in N ways, event M followed by N can occur in M times N ways. So we multiply. Okay, if I have 3 pants and 2 shirts, that gives me 6 possible outfits, disregarding the possibility for things that don't match. We don't get to think about that. Think about when you roll 2 dice. How many possibilities do you have? Well, you got 6 on the first one and 6 on the second one. So you have 36 possibilities. So counting in general is the use of multiplication to find out the number of outcomes for a certain event, situation, something. All right, so let's use the fundamental counting principle. These numbers are going to get quite large, so we are probably going to need a calculator. You're going to want to have one handy. Okay, the photos show Maryland license plates in 2004 and 1912. How many more 2004 style plates were possible than 1912 plates? Well, the first thing you're going to do is figure out what the number of possibilities are for each of the digits here. We've got 3 letters, so we're going to put on 3 blanks, and we're multiplying here. And then we've got 3 blanks for the numbers. So 3 letters, 3 numbers. Well, for the numbers, you've got digits 0 through 9, and that's 10 different possible digits. So each of the numbers you're going to multiply by 10 to find out the number of possibilities just for the numbers. So there's 1,000 just for the number side. And then we're going to multiply that times the number of possibilities for the letters. Now think about it, you got 26 possibilities for each of those. And that's the product you want to find. 26 to the 3rd power times 10 to the 3rd power. Okay, what does that come out to be? 17,576,000 possibilities. So that means you can have a lot of cars in the state of Maryland. Okay, what about just the 1912 plate? We only got the 4 digits, and they're all numbers. So it's 10 times 10 times 10 times 10, 10 to the 4th power, or 10,000. So if you subtract the 2, you're going to get 17,566,000. More license plates are possible now than were in 1912. Go ahead and try the other one. In 1966, one type of Maryland plate had 2 letters followed by 4 digits. How many types of plate were possible there? Try it out. Okay, so you should have 26 times 26 for the letters, times 10, times 10, times 10, times 10 for the numbers. Multiply that out, we get 6,760,000. That's fundamental counting principle. Let's talk about permutations and combinations. Okay, a permutation is an arrangement of items in a particular order. So there's the heat. Nearly jumped out of my skin. All right, so, and I apologize. I know that probably happens too each time. It's good for the heart every once in a while, as long as you don't have some sort of condition to begin with. Anyway, a permutation is an arrangement of items in a particular order. For example, 1st, 2nd, and 3rd place in a competition would be a permutation. If you had 10 kids and they're coming 1st, 2nd, or 3rd place, the order matters. 1st is different from 2nd or 3rd. Ask the silver and bronze medalists at the Olympics about that one. Combination, on the other hand, is a selection where order does not matter. So toppings on a pizza, a 5-person committee from a group of 20 kids. The order doesn't matter. You could pick the people, and as long as they don't have a hierarchy of order, then it's just a group of people or a group of toppings on a pizza. So now you should be able to go back to that meme on that beginning of the video and figure out what it means. Anyway, the other definition we need here is factorial. Okay, when we say n factorial, we're saying that's a positive integer, and we're multiplying n times n minus 1 times n minus 2, dot, 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 3 times 2 times 1. So it's the number times the next number down, all the way down to 1. 0 factorial has a value of 1, which is one of those things in math that we need as a definition. Otherwise, these certain problems will not work the way that we need them to with the formulas that we're going to learn, which are right here. So you have two different formulas. You've got the one for permutation, and it's the letter P here with NR. And this is a permutation of n items in a set arranged r items at a time. So 10 kids, 3 medals, for example, or 10 kids, 4 places, say first, second, third place, and then honorable mention. That's a permutation of 10 things taken 4 at a time. And so it's n factorial over n minus r factorial. And you'll be thrilled to know, I'm pretty sure, and I'll double check this in class, that these formulas are on your formula sheet for the SOL test. So that's awesome. It's just awesome. Okay, so we say that it's a permutation, and what we're doing is we're finding the number of the number of n things that can happen r at a time, if they're chosen r at a time. And so you're multiplying that out, you're dividing off what you're not using here. So because it's 10 people and you're only taking 4 places, the 10 minus 4 divides off the part you don't need. A combination, on the other hand, you end up having to divide off a little more. See, the formula has an r factorial in the denominator, where this one didn't up here. It's because you're dividing off the duplicates. Because in a combination, order does not matter. So if I have red, blue, green, blue, red would be the same thing because the order doesn't matter. Like pizza toppings is the best way to put that. Because even though you may be nitpicky about the order your pizza toppings are put on, it doesn't really matter. The pizza still has those toppings. So these are our two formulas. We're going to need these. Luckily, I wrote them down on my my handy-dandy scratch paper that's sitting with me here with all my problems written out. So I'll be all set with them. But do make sure you copy this down if you're not using a PDF. Okay, we're going to find a permutation of n items. In how many ways can 12 folders, one after the other, be arranged? In how many ways can you file 12 folders, one after the other in a drawer? Well, this is a permutation. Pencil or pen, not pointer. A permutation of 12 things taken 12 at a time. So we can use the formula or we can use the fundamental counting principle with this. If we use the formula, it's going to be 12 factorial over 12 minus 12 factorial. And we learned a few minutes ago here that 0 factorial is equal to 1. So this is 12 factorial over 1, or just 12 factorial. So that means it's 12 times 11 times 10 times 9. 12 times 11 times 10 times 9, all the way down to 3 times 2 times 1. And you can use your calculator for this. I'll show you where to find it on your calculator. It's 479,001,600. That's a lot of ways you can file those folders. Now, obviously, only some of them are going to make sense, but that's the total number of ways you could actually file them. How many ways can you arrange 8 shirts on hangers in a closet? This one's going to blow your mind, too. Go ahead and try it. Okay, it's permutation of 8 things taken 8 at a time. It's 8 factorial over 8 minus 8 factorial, which is just 1. So it's 8 times 7 times 6, etc. And that comes out to be 40,320. Isn't that fascinating? You really never... Oops, sorry. I didn't mean to hit the desk. That was probably loud. You don't really think about that being possible, that's that many different possibilities, but that's 8 shirts, just 8 shirts on hangers. All right, more permutations, one more. 10 students are in a race. First, second, and third places will win medals. In how many ways can 10 runners finish first, second, and third with no ties allowed? Again, a permutation of 10 people in 3 spots. So this time, it is a little different. We've got our 10 factorial on the top. Is n factorial over n minus r factorial. So 10 minus 3 factorial. And this is what you're going to do with these. You're going to start off by, well, what's the denominator? 7 factorial. Remember that if I start writing out 10 factorial, it's 10 times 9 times 8 times 7 times 6, but 7 times 6 times 5 times 4, that's just 7 factorial. So break up the top part just like that. The 7 factorials cancel. And then it's just 10 times 9 times 8, 720 different possibilities. Of course, only one of them will happen, But there's 720 different possibilities. That's why they probably shouldn't try to make the trophies ahead of time unless the race is fixed. Because would you make 720 different combinations of trophies? Okay, let's try combinations. All right. So again, formula. Let me go ahead and write the formula down for you. Okay, let me go ahead and look at it myself. The combination formula of n things taken r at a time is n factorial over r factorial times n minus r factorial. And remember that r factorial in the denominator is dividing off the extras that are duplicates. So, combination of 13 things taken 4 at a time. 13 factorial over 4 factorial times 13 minus 4 factorial. Now, I did a lot of this type of math in computer science and in discrete math, where you're starting to learn about, well, let me get into that in a minute. Come on, LeCompte, get with it. Finish the problem first. All right, 4 factorial is 4 times 3 times 2. I'm going to leave that right there. 13 minus 4 is 9 factorial. So right now I've got this. Now do what we did before and break up that 13 factorial. 13, 12, 11, 10 times 9 factorial. Times 9 factorial. Okay, so the 9 factorials are going to cancel. Now, 4 times 3, that's 12. Then look for another place to cancel. 2 goes into 10, leaves a 5. So it's just 13 times 11 times 5, which comes out to be 715. So if there are 13 different pizza toppings at a pizza restaurant and I want 4 topping pizzas, there's 715 different possible pizzas. Not sure why I'd need to know that, but let's just run with it. Try these 3. I'll go ahead and pause it in a minute and write them out. Actually, I'm not going to pause it. I'm just going to write them out because I don't think this video is long at all. Feels like it was a breeze. I feel like I went through it pretty quickly. All right, so this first one. Okay, but you pause it and try them, okay? Please, thank you. All right, first one, 8 factorial over 3 factorial times 8 minus 3 factorial. And this is a good one. Lots of stuff is going to cancel for this. So the top's going to be 8 times 7 times 6 times 5 factorial. 3 factorial is 3 times 2. And then 8 minus 3 is 5 factorial. 3 times 2, 6, cancels. 56 is our answer. Next one, 9 factorial over 2 factorial, which is just 2, over 9 minus 2 factorial. So that's 9 times 8 times 7 factorial, because the denominator has a 7 factorial, and they cancel. 2 goes into 8, 4 times, 36. Last one, 15 factorial over 5 factorial times 15 minus 5 factorial. 15 times 14 times 13 times 12 times 11 times 10 factorial. 10 factorial. 5 times 4 times 3 times 2. All right, 10 factorial, 10 factorial. 5 goes into 15. So does 3. 4 goes into 12. Leaves a 3. 2 goes into 14. Leaves a 7. So 7 times 13 times 3 times 11. 7 times 3 times 7. Here, look. 7 times 13 times 3 times 11. Multiply that, we get 3003. All right, so go back to that meme on the first page. Read it again and let me know whether or not you get it. Okay, but I do want to say one more thing, so let me go to a new slide. What is this counting stuff good for? Okay, why are we going to learn this? Okay, why do I need this? Why do I need this? Now, when you're thinking about Google searches, you're actually thinking about what a computer's doing is it is searching through every line of text until it finds a specific sequence of letters. So if you search cats being cute, Google, whatever your search engine is searching for this specific order of characters with this spacing in between and everything. And what it's doing is it's going through lines and 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 lines of code to find that. And in order to do that, one of the things that computer programmers have to learn how to do is figure out how long is it going to take. And you're not going to know how long it takes until you know how many possibilities the computer is actually going to have to check. So the basics of finding permutations and combinations and doing basic counting, that's going to lead you into some of the basic computer science stuff that you use in a branch of math called discrete math. So if you plan on doing coding and that sort of thing, you're going to need these basics, and then you move on towards more complicated stuff. So I just wanted to include that information, and hopefully you didn't stop it at the smiley face, because I know I usually stop at the smiley face, but I wanted to finish that, so I'll give you one more very happy smiley face. All right, now I will see you guys in class.